Thanks, guys. I see an awful lot of familiar faces out there. I guess that's because I've been doing this for going on 25 or 30 years. A lot of you guys probably remember back when I used to sell Tormek sharpening systems and demonstrated turning with razor sharp, high-speed steel tools. Enjoyed that a lot, but there's a lot involved in turning with traditional tools. Then I spent several years working for Sorby, again, talking about traditional tools most of the time. But then about 9 years ago, I did a demonstration for your club on the Sorby Turnmaster. And that was a pretty revolutionary tool. It used carbide and high-speed steel inserts on the end of a shaft. And the end of the shaft could turn, so that not only could you flat scrape with it, but you could also shear scrape with it. Really clever idea. We sold a lot of those tools. I sold a lot of those tools. I enjoyed using it, but I always felt that there was a little bit of a problem with it, and that was the little mechanism on the end that allowed you to turn it had to be on the wood side of the tool rest. And so you had the tool rest a little farther away from the work than most people were comfortable with. It really wasn't a big deal, but it was a perceptual deal. And so that was something that held the Turnmaster back a little bit. And the other thing that I was not real crazy about on the Turnmaster, the carbide tips held up really well, but they were never really sharp. They never cut clean like you expect, like I expect, from a high-speed steel tool. So when I was working for Sorby, the owner of Woodpeckers came to me and said, "Jeff, I'm thinking about getting into the wood turning tool business. Do you have any ideas about that?" And I said, "Yes, I do." That's when I came to work for Woodpeckers. That was in 2016. And Rich kind of turned me and an engineer loose to come up with a carbide tip turning tool that was different from what everybody else had and made turning easy, like some of the other people claim, but also allowed you to do some really intricate, delicate work and not start with 80 grit sandpaper. And so what we developed was our ultra shear line of wood turning tools. And the difference here is we are doing shear scraping. I'm getting ahead of myself a little bit here, but just to give you the fundamentals of the idea. We're doing shear scraping with this, but instead of turning the head, the entire shaft has bevels on it. And those bevels give you absolute control of the angle that you're presenting the tool to the work. So we have several different tips that we have available. They all require a different shank. And I'll send some around here in a second so you guys can take a look at them. But basically, they're pretty similar shapes. There's a square, a round, and a point. And those tools give you a lot of flexibility to do a lot of different things, especially with ours, because the square is not just square. We have square, and then we have two that have a slight radius to them. Same thing with the diamond point, what Easy Wood calls a detail tool. Our detail tool, everybody else, if you look at the end of that diamond, there's a radius on there. And we make one of those too. But we also make one that's a full sharp point. And that's going to be a tool that I'm going to use to do some detail work when we start in on this goblet. I'm going to send a couple of these around so everybody can take a look and get an idea of that shape that allows you to shear scrape. If the tool's on here like this, that's your standard flat approach. And here is your shear scrape to this direction, and here's your shear scrape to that direction. And you're not guessing about where that 45 is. It's milled into the shank of the tool. Now our little pin tools are a little bit different. Because they're used for detail work, sometimes you want to vary that angle a little bit. So the shank on the little detail tools is round with a flat on the back of it. There's two things about these tools that make them different from the rest. One is that shank shape. The other is the carbide that we use. We use a very, very unique carbide mix. It's called a nano grain carbide. Very, very small grain structure in that carbide. And what that allows us to do is put a better finish and a better grind on the tool than you can put on the standard carbide. You can see that the face of that tool is polished like a mirror. You won't see that on anything else that's made out of carbide. And then the bevel is not polished, but you can also see that the grinding scratches on that bevel are really, really small. So this all gets back to my old Tormek days. The sharper your tool is, the cleaner it's going to cut. And the other part of that is the longer it's going to last. So we have a tool that lasts a really long time and gives us a really clean cut. Now, turning with carbide tools is different than it is with traditional tools. Traditional tools, we all know that the goal is to ride the bevel. So we're bringing that bevel in and raising the angle up until we get the bevel riding. That can be a tricky thing for a beginner to learn. And what we're doing with carbide tools is avoiding all that because we are basically scraping everything. Now, scraping gets a bad rap, and in some cases it deserves it. But for the most part, scraping can be very effective if you're working with a sharp tool. So what I'm going to do here is hopefully, but we're going to try and turn a goblet. And because I'm a glutton for punishment, I picked up a blank when I was messing around in the basement last night that's way longer than I normally turn in front of people. But we're going to see if we can get a fairly long stemmed goblet out of this today. First thing we need to do is get it round. So I'm just going to take the square tip tool. I'm going to hold it flat on the tool rest and come straight into the work. And I want to work just about on the center line. Almost round. So the tip is made, or the pocket is made in the tool so that we can present that. Typically, the other one that I've got here, we've got mounted normally where it's the square edge is facing forward. And then on this one, you can see that I've got it mounted so that the point is facing forward. And that's kind of cool because now if I want to go in and square up the shoulder for that chuck, it's a relatively natural angle there that I'm coming in at. Now I think that that is about the right size, but I've been fooled before, so I'm going to check. I can take it down just a little bit more. Now, that's the kind of stuff right there that you're probably not used to seeing from a scraper. By the way, don't ever use your hand as a brake on a lathe. Really bad idea. That turned around nice. Okay, so I have the outside of the goblet down to where I'm round, and I got a beginning to a shape. It's getting close to where I want it. So let's start talking about that surface finish that we're going to get from this. We don't have a real crisp picture of it, but this is not bad. It's a pretty okay surface. You know, I would start attacking that with like 120 grit sandpaper. But what I'm going to do now is I'm going to take this tool, and instead of holding it flat on the tool rest, I'm going to turn it at a 45-degree angle. And at that 45-degree angle, now I'm still scraping, but I'm shear scraping. I'm taking a really light cut. And now you would mess that up with anything coarser than about 220 grit. It looks and feels like somebody that knows what they're doing cut it with a skew. That's the kind of surface we can achieve with that shear scraping approach. Okay, now we're going to hollow that out. I'm going to square up the end here a little bit. Now, whether we're talking about the woodpeckers, turning tools, or anybody else's carbide turning tools, it's basically a pretty simple idea. Anything that is an outside curve, we're going to cut with the square tool, and anything that's an inside curve, we're going to cut with the round tool. So, I mean, you can call them roughing and smoothing, or whatever you want to call them, but basically, you're using the square cuts, the square tool for outside curves, and the round tool for inside curves. And when we're hollowing something, now this is in-grain hard maple. This is not a particularly easy cut. But what we want to do is adjust our tool rest so that the top side of the tool, well, I'm not getting zeroed in here. There we go. I want the top side of the tool right on the center line of the work. Now, while typically the instruction manuals and the books will tell you that you want that to be dead straight on the center line, I'm going to tell you in actual practice, there's nothing wrong with having a tiny little bit of a down angle. Another thing that's nice about this compared to working with gouges is that I can work both directions. I'm going to cut from the inside to the rim, and then I'm going to cut from the rim to the middle. And we're going to go back and forth like that. I'm going to be a little more aggressive in the middle. Then out there at the edge of that rim, I need to be a little more cautious so that we don't get vibration. Easy now. This is actually the same size tool. The only difference is the shank's a little shorter. And that's our mid-size range. And now that I'm doing the shear scraping to get my final finish on the inside, I like that shorter length. All I'm doing now is checking to see that my curve is smooth and I don't have any big bumps. That's getting pretty close. All right, I'm watching the chip, and I'm going to come in here and I'm going to do this until I find the angle where I'm getting a nice chip coming off of there and get a flow coming where I can pull that around the corner. And that's, you know, they try and make this sound like it's just all super simple and flat is all you ever need. You can work just dead flat, but you can get some finesse if you will start experimenting with that angle. You saw when I was doing the outside work, I was using a down angle. Now in here, I'm using a little bit of an up angle. Both of them are going to give you, well, it's looking for that chip that's coming off where it's just peeling off in this instead of dust. Okay, now, what I found after making a lot of goblets and blowing a lot of them up in front of people is that you're really best off to rough your outside shape first, about 2/3 of the way down. Then go inside and create a curve that you're happy with and a depth that you're happy with. Then come back to the outside and now match your outside to the inside and get a uniform wall thickness. And at this point, I always want to use my tail rest when I can. But I don't want to go sticking that big honking piece of sharp metal down on the bottom of my goblet right now. So I'm going to that in there. We could do the cone, but this is a trick for everybody that doesn't have one of the fancy ones. I'm just going to take a wad of paper towels, fold that up, put that down. Come on, get in there. Thank you. There we go. Now we've got nice support on our piece, and we're not chewing anything up. Now I'm cheating here because I've got several tools set up. I'm back to the square tool, and I'm using the one that is mounted with the point sticking out instead of the flat sticking out. And I'm using that to sneak around that corner and get a nice smooth curve coming down to the base. Nice and smooth there. Nice and smooth all the way out to my rim. Okay, I'm pretty happy there. Now we're going to start looking at the detail tools. And the one that I sent around to everybody is the full sharp. Thank you. The full sharp, which I'm going to be using in a minute, but right now I want to get this down to the transition between the bowl and the stem. And so I'm going to use the one that has the radius on the end of it. Big tool rest is a little too big right now. Thank you guys for having a little tool rest in your kit. Happy. Now we're getting to that point of just one more cut. Things usually go south about then, but just like that. Stop. There. Okay. Now we're going to make a little Seattle Space Needle out of this. Now, another thing about goblets, if you haven't turned them before and you'd like to try it, there's one hard and fast rule, and that is once you get something small here, you're done here. There is absolutely nothing you can do out on this end of that goblet that is going to be helpful. So you gotta get this done and then start working toward the foot and avoid any temptation to come back out here and touch up something out here because you're just going to blow it up. Trust me. And so if we were actually finishing this piece, I'd be doing some sanding right now. got a good time to take a break here and talk about tools. So right now, I'm on a pretty delicate part of the operation here, and the part that's right out at the front of my tip is still sharp, but it's not as sharp as the rest of it. So instead of running to a sharpening system, I'm gonna loosen the set screw that holds that tip in place. I'm going to turn it about 45, 50 degrees, lock it back up, and go right back to work with a fresh edge. Oh, yes. And I think that's just about as far as I'm willing to push my luck this morning. We're going to go for that as our stem size, especially if I want to make it fairly long. Oops, that was just a little too much. So I'm going to have to do something now that is going to keep everybody from seeing what's actually going on. But I'm going to use my fingers as a steady rest on the back side of the shaft. So I'm going to be holding against the back side of it directly opposite the tool so that I can keep that from vibrating, but you're not going to be able to see very much, I'm afraid. That's pretty good. And we're going to make the transition from the stem to the foot. And we want a little bit of taper on that, but we don't want it to look clunky. And just trying to get everything to blend nicely. Blend nicely. There. There we go. That's in pretty good shape. So I've made a lot of these, and I've made a lot of them in front of people. And some of them turn out really nice and some of them don't. And one of the things that I notice, having made a lot of them, is that one of the critical design elements that is subtle but makes a huge difference is the relationship between the size of the foot and the size of the bowl. If the foot's too little, it doesn't look right. If the foot's too big, it doesn't look right. It's somewhere around even, somewhere close to even. It can be just a little bigger, little smaller, but too small and too big just look weird, especially too big. Looks clunky. This one I think is in pretty good shape. Looks like it. I could actually measure it, but that would be giving in. I'm a little smaller, so I think I'm pretty good. Now, I'm going to start undercutting the foot because he tells people not to do that while he's doing it. About 10 or 12 times a demonstration. You did notice here what we went back to is the detail tool. This is the radius nose one. What's that? I don't have a clue. I hope I was around when I was doing the spindle work. I hope it was around 2,000, 1,800 to 2,400, somewhere in there. Speed is your friend. That's a hard thing for a lot of guys to buy into. They think, particularly when they're beginning, they think, well, if I slow that lathe down, it won't be as scary. And so like when you're doing something like squaring up or rounding up a square, and you stick that tool in there, whether it's a bevel edge tool or a scraper, either one, you have that lathe going click like this, and you stick that tool in there, and it goes thunk, 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 and you feel every one of those through your whole body. Ramp that speed up a little bit, and now the contacts are closer together, and it feels more continuous. And so, I can't remember who it was. There was one of the demonstrators I saw one time. Ooh, I didn't get that very good. It's okay, but it's not great. So somebody asked him how fast he turned, and did the same thing I'm talking about, speed's your friend. And he said that most teachers, most instructors tell students to turn the lathe up until they think it's too fast, then back it off a little bit. He said that's exactly backwards. Turn it up until you're a little bit uncomfortable, and then turn it up a little bit more. Get used to working with a higher speed, and you'll find that your turning really turns a corner and starts moving in the right direction. Push yourself a little bit is the point. Okay, so now we're going to try and get this parted off without blowing it up. And that's why I turned it down before I took the tailstock off. Now I've got my full sharp point on. Trying to minimize the little nub at the bottom. All right, guys. So, thanks. So if people tell you that carbide turning tools are just a crutch, just something that beginners could use but real turners would never touch, let me tell you, I just, about a year and a half ago, I turned my mother's urn, and I thought, well, I'm gonna use my traditional tools. I haven't used them for a long time. Got all my traditional tools out, started turning them, and I was working on Mom's urn and using the traditional tools, and things just weren't going quite the way I wanted them to. And I thought, well, is this really what I should be doing? And I grabbed my ultra shear tools, I went back to work on it, and all of a sudden things started moving the way that I wanted them to. So don't get married to any one thing, and don't listen to anybody that tells you that there's only one way to do it, because there's lots of ways to do any of this stuff. Yes, our tips fit on easy wood tools. And I don't know why you do that, but easy wood tips fit on our tools too. We have the finest grade of carbide and the best grinding of anybody out there. And so anything that any of our tools, any of our tips will fit on the easy wood tools.
How do you sharpen?
You don't.
You don't.
You don't. You can, you can take a diamond card and you can lap them, but you'll never get the level of polish that's on the face of these. That's taken down to a mirror finish. And to do that on carbide takes some really sophisticated diamond equipment. A regular flat diamond stone, the best one you can buy, is going to scratch the hell out of that compared to that surface right there. If you do anything, you can do a little bit on the bevel, But really, the price is not so high on these inserts that you can't just use them up and replace them. Exactly. You just keep rotating it. Obviously the square ones, you've got 4 edges that you can use. The round ones are a little more forgiving. You're really only using a pretty small section up there at the front of that, and so you can get maybe 6 or 7 turns out of a round tool. And then obviously the diamonds are sharpened on both ends, so you can flip those around. You know what? I have been using the same 10 or, I don't know, probably 10 or 12 tools. I've been using the same inserts on all of these for probably, I'm going to say 3 years. And when I looked at that one, there was one edge that was pretty well worn. But yeah, they're not a high wear item. I think that's where Rich got disencouraged, because he thought we were going to be, after we sold 500 or 600 turning tools, we'd be selling 500 or 600 inserts a month. It just doesn't go that way. These they last a really, really long time. Oh yes, on the goblet, yes, that is pretty critical. So if I'm actually trying to finish a goblet, I'm going to sand and finish oil the inside before I come out and finish the outside. And then I'm going to work my way down. Each step each time I change the way that I'm working, I'm going to finish what is above that. So we're going to do a dry bowl, which is not a lot of fun, but I think this one will be okay. We know for one thing it won't move after we get it turned. So I've got a maple bowl blank here, and I had a 3/8 hole drilled in there. I'll thread that onto the screw. Okay. Relatively round. Now we'll give it a shape. Oh, I'm doing that backwards. Yeah, right. Okay, there's the foot for my chuck. Now with our new shape, take that down a little bit more. You all know that there are no mistakes in wood turning, merely design opportunities. See if we can turn my little mistake into a design element. We'll do a little undercut. So what I'm doing on that inside curve is I am not working flat, right? I'm up here on the corner, so that that is coming in. Those fibers are not hitting the tool flat, they're hitting it at an angle. Now, you can hit, particularly when you're getting started, that 45 is pretty reliable. Once you get a feel for it, there's all kinds of little in-between angles that will get you good results, and you just kind of search for the one that works the best. But when you're getting started, just stick to the 45. Hello? Ridges. Hate ridges. What I'm fussing with here is keeping my wall thickness close to consistent around that inside curve. And that is close enough that it's not embarrassing. So there we turned a bowl. Now, obviously, we haven't reverse turned it and taken the foot off of it yet, but that was two tools. The round tool for the inside work, square tool for the outside work.